The objective of this chapter is to learn the concept of exponential function and how to sketch the graph of this exponential function. This is found in the book on page 32. Exponential functions are ones of the form y equal a to the power x. Graphs of these functions all pass through 0, 1 because a to power 0 equal 1 for any number of a. This means that the exponential function is written in the form a to the power x. All the exponential functions pass through the point 0, 1. Why do they pass through the point 0, 1? Because if we take the example x0, we will have a to the power 0, which is 1. And we know that any number raised to power 0, the answer is 1. This rule is found and discussed in the previous tutorials that talk about the laws of indices. So as we have said before, the form of the exponential function is y equal a to the power x, where x is any variable and a is a constant number. A very important thing you must know that a can be any positive number except 1. So a is a constant number that can be any positive number except number 1. Why? Because if we consider a as 1, we will have y equal to 1. Also, let's consider the x to be 1. Now, 1 to the power 1 is 1. So, in this case, the graph will be a straight line with equation y equal to 1. And this never reflects the concept of exponential function. Let's repeat. Exponential function is in the form of y equal a to the power x, where a is any positive number except 1. Now, let's take a look at these examples to see if these functions are exponential or not. Are these functions exponential or not? Let's start with the first equation, y equal 2x squared. As we have said before, the form of exponential function is y equal a to the power x. Now here we have 2x to the power 2. So the index here is constant, and we said that the index of exponential function is variable. So in this case, y equal 2x squared is not exponential function since the rule said a constant must be raised to a variable. Constant and its power is variable. Now let's take the other example, y equal minus 2 to the power x. First of all, x here is very good, but here we have minus 2, which is incorrect. So since we already said that a must be a positive number, but since a is minus 2, which is negative, this is not exponential function. The base must be positive number. Now, y equal 1 to the power 2x. 2x is a variable, but the base here is 1. The rule is y equal a to the power x, where is a constant number. It can be any positive number except 1, as we have said before, and since the base here is 1, so this is not exponential 2. Since the base must be a positive number different from 1. Now y equal 2 to the power x. The base here is 2. That is a positive number greater than 1. So this is exponential function. Now the other example, y equal 2 to the power x minus x. Y equal 2 to the power minus x. Since the variable is x and we didn't determine its sign, so it can be either positive or negative. And since x is the variable and base is 2, that is greater than 1, then this is also exponential function. Now y equal 1 over 3 to the power x plus 4. Here, since the index is x plus 4, this means that if we add or subtract from the variable, the most important is that there is a variable in that index, first condition, and the base is 1 over 3, and it is a positive number different from 1. So this is also exponential function. By this we learned what is the exponential function and its form, that is y equal a to the power x. A is a positive number except 1, and it is a constant number raised to a power. In the coming tutorial, we are going to learn how to sketch the graph of this exponential function.